Everybody eating. Okay. Measures of position. That sounds all like a big word, doesn't it? Well, I'm going to draw something on here first while it's white, so we can actually talk about what it is. All of you know how to read a gas hand on your car, right?
Mm-hmm. I hope so.
Mine didn't work. He passed away in 2014. He would try to be innovative, and he would try to run vehicles off of vapor, off of air. He would run a vehicle out of gas, and then he'd park it, and then let somebody else have to go to the gas station. Okay? He didn't know how to read a gas hand, or he knew how to read it too well, whichever one it was. But which way do we read?
Left or right?
Left to right. So this is empty. And what's this right in here?
34.
That's a quarter, right?
Quarter of a tank.
Quarter of a tank. So that's your first.
Oh, it's not 5.
What? Quartile. Now, first quartile is also the 25th percentile. So that's a quarter. And then somebody tell me what this is.
Half.
Half. And that's your second quartile, or your 50th what? Percentile. And then we come over here, and what is that? 3/4, which is your third percentile. I mean, the third quartile, 3/4, like you said, third or whatever. Third quartile. Somebody tell me what percentile it is. 25, 50?
75%.
75th percentile. Okay, so you're talking about empty, 25% of your data, 50% of your data, and 75% of your data. And this over here is 100% of your data. Now, also make a note, your 50th percentile or your second quartile is also called your median. Write that down. On this side, the empty is called your min. And on the right-hand side, if empty is the min, what do you think full is?
Max.
Max. So whenever you have data, you already have the min and the max without even doing any calculations. You just put it in order. Now, some people show it like this. Here's your data. Here's 25%, here's 50%, here's 75%, and here's 100%. I don't do it that way. I think it's easier for people to understand, kind of like a fuel gauge. And if you think about it, I showed you the empirical rule. This is 2.5%. This is 13.5%. And this is 34%. What do you think those three equal if you add them together? I'm sorry, what? 50%. So if you take those three numbers, 2.5, 13.5, and 34, and you add them together, you get 50%. Now, when you get in Math 120, you start to show where the 25th percentile is. And the 25th percentile, this is 16%. So the 25th percentile is going to be right in here somewhere. I'll just write, and you get a number down here, that's the 25th percentile. But it's going to be in this area, general area right in here. Okay? Now, there's two things that come with quartiles. What is it? What's so funny?
I was wondering what was on his sandwich. It was poppy seeds. I'm listening. Keep going. It's fine.
That's what it is. She hates me. She actually does not want to listen to me. Okay, that's all right. Anyway, we've got numbers, and then we've got the percentiles. Now, what does that mean? Well, let's say that we do. Let's write down these 8 or 9 numbers. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay? And let's go ahead and put 20 down there. Let me see if I can move this thing around a little bit. Let's put 20 right here. All right, let's say these are just numbers. They could be test scores, they could be ages, they could be shoe sizes, whatever the case may be. Now, I want to find the first quartile, the second quartile, and the third quartile, and I want to write a 5-number summary, and that's what those are called, and I want to put it in a box plot. Then what do I do? Well, the first thing I do is I find the mean. There's the mean. So I'm going to go over here and I'm going to write 5-number summary down. Whatever. Hold on a minute. Let me get rid of the arbitrary things that show up on this board. All right, so 5-number summary. 5-number summary consists of the mean, first quartile, second quartile, third quartile, and the max. So the mean is 2. The max is what? 20, Hubert. That's right, class. And then the median, how many numbers we got? 1, 2, 3, 4, 5, 6, 7, 8, 10. So we got to take the middle 2 numbers. 1, 2, 3, 4. So the median is equal to 10 plus 12 divided by 2, which is what, 11? So 11 is our second quartile, which is called our median. Okay? Now, I'm going to take a red dot. And I really don't like to use, I'll use something else, magenta. And we're going to put that 11 right there. All right, now it's not a real number because it's a median, it's calculated, so I'm going to put a circle around it. How many numbers are above that 11? 1, 2, 3, 4, 5. How do I find the median of an odd amount?
The 2 numbers in the middle?
No, that's an even amount.
Oh, sorry.
You just find the middle, right?
Oh.
See, if you didn't hate me, you would listen more.
I'm praying about it.
Okay, good. Make sure you read some scripture too. All right, so 1, 2, 3, 4, 5. And what do you do with that? If the n is odd, you what? You pick the middle. And that is our first quartile. And it's easy. So 4 or 6 is our first quartile. Then y'all tell me what the second quartile is. Or, I'm sorry, third quartile. What's the third quartile?
Hang on, wait 1 second.
I'll just go over here and sit down and wait. What is the third quartile? I showed you how to get the first quartile.
16?
I'm sorry, what?
16.
I am very impressed. Who said that?
I did. Mackenzie.
Miss Phillips, I am very impressed.
Why?
See, Miss Johnson would know that if she wasn't playing on her phone.
I know. Trying to read scripture.
Actually, that comes from my daughter. She don't like horror movies like Miss Johnson. And me and my son, we were wanting to see The Nun. And we were saying, and it was the night before The Nun came out. I think The Nun came out on Friday night. So on Thursday night, we were sitting there eating, and Walt said, "Guess what? The Nun comes out tomorrow night." And my daughter looked at both of us and said, "Y'all need scripture." So it was you just had to be there because it was funny the way she said it. So anyway, I'll shut up. That's your third quartile. Third quartile is 16. So that goes right here. And that's how you find the 5-number summary. Now, what do you do with the 5-number summary? You make a box plot. Now, there's 2 parts to a box plot. There's part A, which is the number line. I'm going to put this in black. Box plot, that's right, box plot. There's 2 parts. First part is the number line, which contains the min, the max, and the midpoint. And then the second thing, you plot quartiles on number line. That's it. So we need a midpoint. So how do you find the midpoint, somebody?
It's in the middle.
Midpoint. Midpoint. Tell me how to calculate it. If you can't tell me, you should drop this class and quit school.
Hang on.
Oh, God, y'all are such a disappointment.
High plus the low divided by 2.
I am impressed. High plus the low, so 20 plus 2 divided by 2 is equal to what? 11. So in this case, the median and the midpoint come out to be the same. That's not going to always happen. So I'm going to draw a number line. And I'm going to put the minimum 2 right here. And I'm going to put the maximum 20 right here. And the middle is 11. So I've just used the max, cross it out. I've just used the min, and I've just used the midpoint. So I just did the first part right here. Now, before I plot the quartiles, I need to find the middle of the middle of the middle. When you find the middle of the middle of the middle, you're graduating your number line. What does graduate mean? No, it doesn't mean stop, get out of school. That's not that. What does graduate? Like a graduated cylinder. What does a graduated cylinder mean in chemistry?
It's like scaled.
It's marked, yes. It's marked to where you can measure. Okay? Our number line only has 3 numbers on it. Why does that not help us? Because you got to have numbers in between them.
Numbers.
Exactly. So I'm going to find the middle of the middle of the middle of the middle until I have enough numbers to where I can plot something on that number line. So find the middle of 2 and 11. Well, 2 and 11 is 9. Half of 9 is what? 4.5. 4.5 on to, that'd be 6.5, which is 7. So I'm going to put 7 right here. And what's 11 plus 5? 14. 15, whatever. It's close enough for government work. 15. All right. What's half of 2 and what's half of 5? 2.5. So add 2 or 3, whichever. So that's a 5. Add 2 or 3, that's a 10. Add 2 or 3 right here, that's 13. Add 2 or 3, that's 18. That's good enough. Now we have it graduated. I found the middle of the middle of the middle of the middle, and I just fill it. Do we worry about decimals? No. We're not worried about decimals because we're not going to be plotting that close. We're just going to be sketching out a box plot of this.
Gotcha.
So now I'm ready for part 2. So I'm going to take my handy dandy aqua color, and I'm going to put my 6 right here. I'm going to do that one, 6. I don't look like the color I picked. Oh well, let me pick another color, blue. Okay, so I'm going to put the 6. That 6 is going to be right in here. That don't look like the blue either. I guess it's just not going to change. Oh, there's not much difference there. Oh well. It's Russians. Okay. Where is 16? 16 is right in here. And 11 is right there. And there is my box plot for this set of data. That's how you draw a box plot. You do the number line first. The number line consists of the mean, the max, and the midpoint. And then you find the middle of the middle of the middle of the middle. And then you draw your 3 inside numbers. You put that on the box plot. Now, what does this show? This shows that we have pretty much a what curve? A normal curve, because what does the midpoint and the middle and the median do? They're on top of each other because they're the same what? They're the same number. So that means you pretty much have a normal curve. What if all your data was over on this side? Okay? If all your data was on this side, you would have this would be down here like this. And you would have that, which is skewed left. Write that down. That is skewed left. When all your data, skewed right. When all your data is on the left-hand side. Skewed left or skewed right.
Which one is it?
Just be quiet for a minute. Skewed right, she's trying to be funny. Skewed right is when all the data is on the left.
Well, that makes sense.
Hey. Somebody's gonna make a good wife up there. Hey, which one is it? Fine. Skewed right or skewed left is when all the data is what? All the data is on the right. All data on the right. I'll show you an example on the next screen. Well, I'm going to go ahead and erase this screen because they're going to go through all of this what we just went through. They're going to go through all of it on this measures of position. And I'll go over it again on the white screen. So let me clear that. Let me clear it again. There. And let's see what they show us. I don't use these PowerPoints very often. I want to make sure I cover everything because I want y'all to get y'all's money's worth.
Thank you.
Yeah. Quartiles, percentiles, that's what we just talked about. Four equal parts. Let me guess. 25, 50, and 75. See? That's the way they show you. I show you with a fuel gauge. Order from smallest to largest. Second quartile, and we're going to go through this in another. They're probably going to give us an example. We're not going. I've already went through this. Okay, put that in order. Let's see if it puts it in order for us. There you go. All right, write down those. Yeah, write down those. Now I'm going to write them in vertical form. I'm going to write them vertically. whenever you get through writing. So if you want to write them vertically, that's what I would do. Now, usually when you have a 5-number summary, all your sets are going to be more than 5 numbers. Why?
Because you have to have 5 numbers?
Yeah, because to be a 5-number summary, you have to at least have 5 numbers. But 5 numbers is not enough. Okay, 5 numbers, you pick the first number would be the mean, second number would be the quartile, first quartile, third number, that wouldn't work. So you have to have at least 5, but more than 5. So that's why most of your 5-number summary groups is going to give you like 15 numbers or 21 numbers or something like that, because it needs to be at least above 9 or 10 for you to get an actual number. I don't know if I'm going to be able to write all these down. I'll start at the top. 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 21, 21, 23, 24, 25, 27, 31, 36, 39, and 42. So somebody tell me how many numbers that is. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. 27?
Yes.
Is 27 odd or even?
Odd.
Odd, so we just find the middle number. So 27, what's half of 26?
13.
13, so we need the 14th number. So let's count down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's a miracle. 17 is our middle number. How many numbers are above 17? We just counted them. 13, Hubert.
13.
Right? Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What do we do when we have n is equal to 13? We just find the middle. So what's half of 12?
6.
So we got to find the 7th number. 1, 2, 3, 4, 5, 6. 9 is our first quartile. Now let's count 7 down. 1,
24.
3, 4, 5, 6, 7. It's a miracle. 24. So now our min is 2. Our max is 42. Our first quartile is 9. Second quartile and median is 17. And 24 is our third quartile. Let's go to our handy dandy box plot. 2, 42. 42 plus 2 is 44. Half of 44 is what? 22. 2 to 22 is 20. Half of 20 is 10. 10 plus 2 is 12. 10 plus 22 is what? 32. 10, half of 10 is 5. That's 7. Half of 10 is 5. That'd be 17. 10. I'm sorry, half of 10 is 5, it'd be 27, and 37. And if you wanted to go further, half of 5 is 2 to 3, so this is going to be a 5. Half of 5, that's 9, 14, 19, 24, 29, 34, and 39. That should be enough for you. Now I'm going to take my handy dandy red marker, something distinct from blue. I don't like to write in red, but I'll get over it. So we've done this. done that. So all we got left is those three numbers. A 9 is right there. 24 is right here. Uh-oh. This don't look good. 17 is right here. Where is the middle? What's the middle number?
17.
17.
Nope. The middle number is what? Oh, shoot. Leave me alone. You don't like making fun of me, don't you? What?
We're sitting here talking about you.
Who is?
Who do you think?
You?
Yeah.
Why?
Because we were like, why is 22 in the middle?
Midpoint, that's the middle.
But we just said 17 was the middle.
That's the median. Now, what's wrong? What's wrong with this picture? They're not what?
It's not the same.
Not the same. So at this point, Ms. Johnson, being the good student that she is, even though she don't like it, okay, and Ms. Phillips, Mr. Robinson, they're still asleep, okay, they find out that the median and the midpoint is not lining up, and they say, whoa. Now you have the hump is not in the middle where it's supposed to be. The hump is on which side of the 22?
So,
The left.
left side.
It's the left. So that means your data is on the left side of the center, which means you have a skewed right. It's always the opposite. It's always the opposite. Here's all your data right here. Now, let me put this in perspective for you. Here's the middle. Let me draw a picture of the middle here. The middle is your midpoint. There's the mid. God, my, that's pretty straight. Wow. That's pretty straight. I think I did a real good job there. Anyway, I know y'all won't compliment me, but at least I compliment myself. All the data is on the left-hand side. Now, put this in perspective of you. How many of you have been in a class and the teacher was a real crappy teacher, okay? And be quiet, Miss Johnson. And do not name the teacher, all right? I don't need that. I don't have my sunglasses, all right? And they give you a test, and the average of the test is 42, and you made like a 36.
Oh, been there.
Okay? And everybody in the classroom made below a 50. Nobody made 100. Nobody made a 90. Nobody made a 70. Everybody made a 40 or a 50. What does that say? It says two or three things. Give me the three. There's three possibilities and a fourth possibility. Can I name one of them?
The teacher.
The teacher always, it's always the teacher's fault. Okay? What's the other reason? No, not the school system. We can't bring in politics, okay? Not the school system, okay? That has a lot to do with it, but we're not going to bring that in. Well, give me another reason that there would be a lot of bad numbers.
Inside.
The teacher or the student?
Yeah.
Okay, the students didn't study. All the students? That's a question. What's another possibility? The teacher sucks and the students wasn't listening. That's the third. That's like the double whammy. That's like pouring gas on the what? Okay, forget it. On the fire. Thank you, Mr. Robinson, 15 minutes later. Thank you. What's the fourth option? The test could be invalid.
Yeah, it's calculated wrong.
Or, yeah, that could be a possibility too, but for every single one, there's two of those possibilities that could not be. One, calculated every single test wrong, and two, not one single student studied. Those two are invalid. Why? Because one thing is perfectly, you can bet on. There's always one. What does that mean?
There's always somebody gonna mess it up.
There's always one person going to mess up the curve, or there's one person going to mess up a good thing. There's always one person that's going to make 100 on the test, and everybody else made a 40 on it. Okay? Always. Now, let's talk about this statistically and logically. We've just thrown out that the teacher graded every one of them incorrectly. That's kind of hard to do. It's also kind of hard to do for nobody to study for the test. Because there's always going to be that one student that goes behind everybody's back and say, well, I'm going to study for the test. Even though the class don't want to study for the test, I'm going to study for it. I'm going to make an A. And they make an A. Nobody made an A on this one. Remember, nobody. So those two are out the window. So that leaves what? An invalid test. The teacher really sucks. That's pretty much it. Okay, now this is not picking on the teachers. That's not what I'm doing. What I'm trying to show you to do, what I'm trying to tell you what to do or how to do it or show you is that when you have a skewed left or skewed right curve, which means all your data is on the left, that means something is what?
Wrong.
Something is wrong. Okay? Something is wrong. That's why you show this, that's why this is so important for y'all. When you see something and you see a curve that looks like this, and the teacher throws up those grades and you say, whoa, something's wrong there. Yes, the test was invalid. What does that mean? Maybe the test didn't cover what you did in the class. Okay? Or the teacher didn't cover what the test what?
Was on.
Was on it. Why does it have to be those two things? Well, Mr. Robinson, have you ever been in a class where the teacher sucked, but a student still made an A?
Yeah.
Okay? Everybody has. All right? It doesn't matter what the teacher does. The teacher can turn around and turn up cartwheels. There's still somebody in there that's going to make above a B. But when you're talking about all students did not make a C or better, that means that the test was the wrong test or the teacher did not cover the material that was on the test. So, it just shows you a little bit about how you think. Now, what's the other alternative? Let's say we have this, and I'm going to do this in green. Okay, you with me? Mm-hmm. What if we have this? All the data is on the right.
That means the grades were good.
That means the grades were very good. Maybe too what?
Too good.
Too good. Why? Because just like you have a person that's going to ruin the average with a bad grade, what are you going to have on the other side? You're going to have the DA that runs the average for the good grade. The deadhead. The Bubba that sits at the back of the room, don't know what day it is. Okay? You're going to have that student. All right? But does this mean that the teacher should be given the Apple of the Year award, or what is that thing they give on WYFF? The Apple Tree Award, whatever.
Golden apple.
Yeah. Should that teacher be given the golden apple, or does all those students, are they just that smart? There's something wrong here too. Okay? So, now, what if you have this? What if you have, and we'll do this in the aqua color, what if you have this?
Then it's normal.
All right. That's normal. Okay? All the data is falling in the middle. Remember, the most important thing about statistics is the what? Starts with an M. Middle. Thank you.
You're welcome.
So you feel good about yourself now?
Yeah, and wear sunglasses inside.
No, you don't have to wear sunglasses inside. When you feel good about yourself, you don't have to do that. You don't have to carry around a water jug full of water. You don't have to raise your truck up in the air 15 feet.
Stupid on the
Or put $10,000 worth of video and tires on a $1,000 car. You don't have to do that either.
Okay, good. I don't have the money to do that.
Well, a lot of people don't, but they do it anyway because, shut
Makes them
up.
cool.
Because people are stupid, that's why. All right, that was 12.3. We covered most of that the other day, so let's move over to 12.5 or 12.4. Y'all know we're going to finish early. Y'all know that, don't you?
Yep.
Okay. Just didn't know if y'all put 2 and 2 together yet. Some people it takes, about the last 2 weeks of school, I get somebody who goes, we almost finished. You think?
So when does that mean that everything will be open?
When I start getting toward that, when we start working on that autopilot questions, that's when y'all probably are about finished.
Okay.
Measures of dispersion. Oh my gosh, look at there. We've already done this. Oh my gosh, well what the heck was 12.3 for? Let me see if I covered everything.
Oh.
That's it. All right, so what we're going to do, I'm not letting y'all go because that'll just make you happy, and I don't want to make y'all happy. So,
And it is Halloween, so you don't want to.
Yeah, it's Halloween, and I don't want y'all acting stupid.
What are you going to be for Halloween?
Oh my gosh, let me tell you, I'm going to close the door.
Oh God.
I hate Halloween. I hate it, okay?
It's my
Why
favorite
do I hate it? I don't hate it because of the kids. I think the kids are cute. I think that's cute. And I like to go to parties where women dress up like sluts and, dress up and, I like those too. But when you wear costumes to work and school and you're the only one that does it, you look like a fool. Okay? And you're tying a sign around your neck that says, I really need attention. I don't get it at home. I had a student this morning, okay, dress up. And this student did everything they could to get me to call on them because they wanted me to see, because I ignored them. They wanted me to see their costume. And it was one of these goofy costumes with a big wig and all this, and I ignored them. The whole time I ignored them.
This person got to be about my age if they did that.
I'm sorry, what? You're in the back of the room, Mr. Robinson. What?
I said they got to be older, like my age, because teenagers don't do that.
Yeah.
They had been older.
And then you got the half-ass people. Okay? They didn't get a costume, but somebody at school got a costume and they decided to try to half do a costume while they're at school. So they end up taking the person's spray paint and spraying it in their hair, and they walk around with half blue hair, and it's just stupid. I hate Halloween. I hate it. Okay, I'm through. I'm through with my rant.
So you're not dressing up then?
Y'all think I'm crazy, don't you?
Yeah.
Mm-mm.
Okay.
I don't.
As you say, I'll meditate and pray about it.
Right.
I not only pray, but I meditate too because I have to.
I meditate. I fall
I have to
asleep.
have both. I have to have both.
Meditate.
All right, here we go. Let's go with, I'm going to go with and this would be a good one to end the class on. I'm going to go to the spreadsheet, and we're going to make it a little bit bigger so y'all can see, so y'all won't moan and complain. Y'all going to moan and complain anyway, aren't you?
Yep.
All right, I want you to do everything we've done, and then I want you to do the 5-number summary and a box plot. So I'm going to give y'all 17 numbers. I'm going to try to give you 17 numbers. So let's go with the prime numbers. 3, 5. Well, I have to use 2. 2. Actually, you can use 1, but we're not going to. 2, 3, 5, 7, 11, 13. What is the next one? 17? 17, 19, 23, 20, 29, y'all help me, 31, 37.
Why do you want to do prime numbers?
Just to piss y'all off. 37, 39, 43. No, just to do them. Because if I did any other numbers, it'd be easier, I guess. I don't know. I'm weird. 47 and 51. Okay, we'll do 15 numbers. There you go. 15 numbers. I want you to do everything. Mean, median, mode, range, mid-range, variance, standard deviation. Draw the curve. Put the standard deviations 3 to the right, 3 to the left, and let's do a 5-number summary and a box plot. And if you can do all of that, you've done Unit 1 in Math 120. And you should feel good about yourself. But make sure you take my Math 120 because everybody else sucks. Y'all like Halloween?
Yes.
I could care less.
I could care less.
I don't like it.
We go all out in our yard. This year we made a castle. That was great.
Well,
Your little girl's gonna dress up.
different strokes for different folks.
My son's like that.
Oh, I didn't know you had a son too. I thought you had all girls.
I'm not a decorative person anyway. The most decorative I get is I put a Christmas tree, and that's about it. I don't do anything else.
Do you at least decorate it?
Huh?
Do you at least decorate your tree?
No, I just throw some stuff on it. Whatever's in the house, aluminum foil. I'm just kidding.
Oh my god.
Actually, we put it in the corner of the room, cover it up with a sheet, and when December 1st rolls around, we take the sheet off of it. Yep. Because when you walk into my house, you don't see that corner of the room. But when you turn the lights on and all of it, you see it. So nobody ever sees it. People come in my house, they don't even see it. People don't come into my house anyway. They don't like me.
You probably don't invite them in.
I don't. Stay there, tell their ass, stay outside. People react funny to dead bodies. So
What?
just keep them out. Let's see, what time is it? Okay, I'm going to give y'all 2 more minutes to do some of this stuff, and then we'll do it, because some of y'all are going to start to explode at, start to self-combust. I need to call the roll. Can't have perfect attendance.
No. Do it.
How do you do the variation?
Variance is where we do you got to subtract it from x, and then you got to square it and add them all up. And that's your numerator. We did a couple of problems. You should remember that.
Yeah, well, I forgot.
I saw it. I should remember a lot of things.
So disappointing.
I found it in my notes, if that helps.
Wow. What a concept. I need to start telling all my students to write in their notebook.
Do I still suck?
Yeah, it could be helpful, you know?
Yeah.
What would we call it? A notebook, maybe? Submit. Everybody's here except for Mr. Gilstrap. Now, Anderson. Anderson sucks. They don't never show up. They just a bunch of drunkards. Miss Candace is still asleep. She ain't even responded. See, I told you she was asleep.
I was asleep. I'm sitting here doing math.
Good. I just want to make sure you're paying attention. All right, so when y'all tell y'all to leave, y'all can leave now. All right, let me get back to my spreadsheet. Actually, class don't end till 2:10, so we're okay.
So you take the number and you subtract the mean, right?
You subtract the mean from each of the numbers. So I'm going to go over here and I'm going to do the mean.
And you
Divide
can't
by
round
15.
it,
What?
right? You can't round the mean when you do that?
I wouldn't round anything till the very end. Make sure you carry at least the 3 or 4 digits. In statistics, you never round until the end of the problem. So that means carry everything to 3 or 4 digits. Now, I'm going to take that mean away from every one of these. So I'm going to do it for you on the second and third column. I'll do it for you. So that's equal to this number minus this number, F4, and then I'm going to copy that down. Oh my gosh. There we go. That should be the numbers you got. And then the third column, what do we do to the third column?
Don't you square it?
Square it. We square each one of these, and that makes them all positive. So those are the numbers you should have for your variance. Hold on a minute. There you go. We're going to add all those up in just a minute. So, what is the median? How many numbers do we have?
15.
15. So that would be the middle, which is number 8, right?
19.
Right.
So that's equal to, and somebody tell me if we got any modes, because I don't care about the mode.
No.
No mode? I thought I had, okay. So median, oh yes, prime numbers, so we don't have one. All right, so hold on a second. Let me get to this and delete. There we go. Mean, median, mode. Make sure you don't put 0. range. Somebody's going to say, you spelled that wrong. All right, range is equal to the highest minus what?
Lowest.
Minus the lowest. And the mid-range, which we're going to use on our 5-number summary, is equal to, parentheses, the highest
26.
plus the lowest divided by 2. Variance, since we've already done the work, is equal to the numerator. Let's go down here and find the numerator. Let's do the sum, and we're going to add up all of those squared numbers, and that's your numerator. So that's going to be equal to 3 blah 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 3769.7 divided by, what is 15 divided by, or 15 minus 1?
14.
14. There's your variance, and your standard deviation is equal to that square root, or raise it to the 0.5 power or 1/2 power. I'm going to raise it to the 0.5 power. And that's your standard deviation. So now I'm going to go over here and I'm going to put 5-number summary right here. 5-number summary. And I'm just going to put min, first, second, third, and max. And of course the min, we don't have to even calculate that. We just have to bring that from here. Bring the max from here. Bring the second from where? Median. Now, how many numbers are above 19?
7.
So there is your middle number. Dang old French for blue. Y'all didn't know that. Y'all are impressed, aren't you?
Please.
Dang old Verde. That'd be what number? Well, there's 7 numbers right here. So it's going to be 37. Good job. And now, oops, now you are ready. I don't know where that came from. It's a conspiracy. Oh, shoot, now I done messed up big time. I suck. Will you please stop? There. Okay, so now I'm ready to draw my standard deviations. We'll do that down here. And equals the middle is the mean. And then we're going to equals the mean plus the standard deviation. I'm going to hit F4 because I'm going to copy it. And that'll be those numbers. And then equals this minus the standard deviation, F4. And I'm going to copy that. And that's those numbers. And I'll draw something on it in just a minute, okay? Now let's do the 5-number summary. So we've got the min right here. And we've got 1, 2, 3, 4, 5, 6, there we go. And I'm going to put the max there. And the gosh, I'm fixing to lose it. It's time for me to quit. Equals that, oh, the midpoint. Where's the midpoint? There it is. Okay, so let's do two numbers here. So, well, 26, half of 26 is what?
13.
Or, I'm sorry, 2 to 26 is 24. Half of 24 is what? 7? Or 4, I'm sorry, half of 24 is 12.
Well,
So 14 goes right here. So I've got it messed up. I should have had 3 right here. So how am I going to do this? Put a 14. Hold on. I just might as well quit. Let me do this, and this, and then this. So I'm going to put a 14 right here. All right. 2 to 14 is 12. Half of 12 is 6. 6 to 12 is 8. 14 to 26. Half of 12 is 6. 6 is 20. So you put 20 right there. And I'm just adding 6. 32. Adding 6. 38. Right? 38 right there. And add 6 is 40 what? 44. There. Now let's do blue. Blue is 7. Green is 37. And the middle is 19. And your box plot is pretty normal. Well, tell me why they're normal. Tell me why it's normal.
because it's not too far to the middle.
Because they're in sequence, right? The numbers are in sequence. But why do we have a little bit, because this, what's the middle? The middle is 26, right?
Yeah.
Why do we have just a little bit of a hump right there? Because most of your prime numbers are on the bottom end. Because we have 2 and 3 and 5 and 7. And then what happens as they get bigger? They start to what?
Get further
Start to
apart.
spread out. Look at your numbers. Go back over and look at your numbers. How many do you have before you get to like 15? Or before you get to 7? I'm trying to get to my numbers. Hold on a minute.
3.
Hold on, I'm trying to get there. There. Look there. 2, 3, 5, 7, 11, 13, 17. And then around 19, what does it start doing?
It increases a lot.
It starts spreading out. So most of your numbers are to the left of what? Center. That's why. Okay? Now, your curve over here shows you that in your general population of your numbers, where's the middle? The middle is right here. Here's your curve, meaning that most of your numbers, 95% of your numbers are going to fall between 55 and what? -10. Is that true? Yes. Okay, because your last number is 51. So most of your numbers are falling between those two numbers. Okay, why do I have negatives? I have negatives because where are most of my numbers? On the left side of what? The middle. So that's why I'm tending toward the left-hand side. It's kind of like, I hate to use this analogy, but when a big person gets in a car, what happens to the car?
Kind of tilts.
It tilts. Same thing here. Why do we have negative numbers over here? We have negative numbers on your normal distribution because where is most of your numbers clustered together? On the left side. See, you can see some of this stuff if you actually know what you're doing. All right. Question. Great. Complaint. Y'all realize we are through with 12.4.
Yes.
Okay. So that means Monday, or when y'all come back Wednesday, we'll be going through nothing but 12.1 to 12.4 questions. Then we're going to move over into the previous section, which is probability. No test yet. We're going to do test, one big test. All right, y'all get out of here and have a good weekend.
Happy Halloween.
Yeah. You should go home.
Okay.